Welcome to another day of school. Well, we are on our 79th day of school. 79. Now, this was the 79 out of 100 when we had our whole party, but we're just using the numerator now as a number, knowing that we have 79 days left of school. All right? And so what we're going to do is we're going to do some fun stuff with this 79. We know since we have 79 days left of school, we know the denominator, or if we're asking in a question, what is the percent of school we have left? Well, you would have to, what has the whole been cut up into? What are all of the days of school? Well, we know it's 180. And so, in order to solve this problem, we know that we first have to look to see if we can simplify it, because we know what we have to do in order to convert a fraction into a percent. We have to read it like a division sign. 79 divided by 180. Well, 79 doesn't have any factors that 180 does. Now, yesterday we were able to simplify it pretty simply, but this might take a little bit more work, but that's okay, because any sort of a challenge makes us stronger. So let's rewrite this in a way that we can solve it. 79 divided by 180. 180. Now, how many times does 180 go into 79? That would be none. And so what we have to do is we have to cut up 79 into 100 equal parts. And that's where the percent comes from, because per means out of and cent means 100. And that's how we do this when we add the decimal point and add our two place values to the right, because this place value means we've cut it up into 10 pieces or tenths, and the second place value to the right of the decimal point means we've cut it up into 100 or hundredths. Well, I just bring the decimal point right up and make sure you always keep them in a straight line. And to keep their place values, you want the ones place value and the tenths place value to be on the same side of the decimal point. And if the decimal point were to go up here, you get all sorts of confused. So anyway, 180 goes into 7, no times. 180 goes into 79, no times. Now 180 goes into 790. Now, sometimes kids, when they get a problem like this, they will take 180 times 1, 180 times 2, 180 times 3, and they'll keep doing all of those problems until they see what number is closest to 790 without going over. Well, I want you to use something that you learned in 5th grade, and it's called your estimating. So if I look at 180, what number can I estimate that to that makes it pretty simple? Well, I know that if I round 180, front end estimate, I'm going to say it's about 200. Can you see how I did that? I looked at the front or front end estimation, circled the number next to it. Is it 5 or higher? Yes. So I just made that 200. So now I look over here and I ask myself, how many times does 200 go into, now I'm going to front end estimate this. What is 790? Because we're just ignoring this decimal point here. We've already put it in the quotient there. How many times does 200 go into 800? Well, our guess would be twice. Now, if you want to, on a separate piece of paper, so you don't muddy this up, 180 times 2, 0, 16, 2, 3. Oh, wow. That's not going to go, is it? Oh, that's why. Okay, I wasn't thinking here. Let's try this again. How many times does 200 go into 800? That would be 4. You see, that's why we do this on the side, because we see that if we made a mistake, and I knew I made a mistake because that product was way too low. And that's what, now I could start this video over so it shows that I didn't make a mistake, but I think it's good for you. You see, hey, it's good to estimate, put your numbers here, and then I re-estimated here and realized there was no way that was the right answer. So I had to second guess what I did, and I realized that I did a Freudian slip there. I was thinking about the number 2 here, and I said it. But it's 4. We know that 2 times 4 is 800. So let's try this again. On the side, we take 180 and we multiply it by 4. Because when I estimated how many times 200 goes into 800, it should have been 4 times. Now for 0, 4, 5, 6, 7, 720. Now that looks more like it. So 720. Subtract, and I get 70. Bring down my 0, and I'm going to do the same thing, except for look, I don't need to even estimate, because look at this. I already know the answer of 180 times 4, and it's 20 more than what I need here. So I can automatically know that it's going to be 1 less. So it's going to be 3. So 4 will be here, and 3 will be here. 3 times 0 is 0, and 3 times 8 is 4, and 3, 4, 5. So now I have 43.66, and I can keep going over here. I know that this number would be, because look at this, 7, 5, and this is a 6, so I know it would be less than a 5. So I don't even need to go ahead and do that. I can just estimate my solution knowing that the number that would be here in 600 would be another 3. And if that's the case, then I wouldn't need to do this in order to estimate up and call it 44. Okay, so I'm not going to figure to the thousandths place value. Now, if it was over 5, if it would have been like 800 or something, I probably would have, or maybe a 900, I probably would have done it to see if this would have been 5 or higher, so I could round up. But anyway, I know it's going to be 43%. Now, I know this is a long video, and every day, hopefully you're going to catch one thing new. The thing I wanted to highlight is the whole reason I used 180 is because that was part of my question. If I said, what percent of the school year do we have left? You had to know that there were 80 days left, and you had to know that the denominator was 180. But what if I would have said, what percent of the school year did we already go through? Well, instead of using, it's 180, instead of using 80, I would have used 100. But without doing that, looking at this number, if we have 43% of the school year left, instead of doing this, what would be my answer if I asked how much of the school year have we gone up? What percent of the school year have we already had? Well, I can just subtract 43% from 100%, right? Because if we have 43 left, that means that everything over, because percent means the whole, we know for certainty that it would be 57%. So we've gone through 57% and we have 43% left. Well, this is getting exciting. Just exciting. Look at all this math. And I am very grateful that you've been following this diligently, and where it seemed redundant and it might seem like always saying the same things over again, hopefully now that we're putting all in piece, it's going to not be quite as such a challenge to the point where you guys become the experts.